Welcome to today's episode of Hyperbolic Orbits. And in this podcast, you get to learn from real life aerospace professionals to how to actually start a career in the aerospace sector and what it is like to work in this industry, be it anywhere in the world. Today, I have the pleasure of speaking with someone who has had a career in the aviation industry for over 15 years now. Her name is Lakshmi Shree, and Lakshmi has been working as an aviation systems engineer. She has had the pleasure of working across different continents, and she has a very rich experience of working with people from diverse cultural backgrounds. She has worked on different kinds of aircraft systems, air traffic management systems, test systems, and measurement systems too. And the good thing is, she believes in solving multidisciplinary complex problems using the concepts of systems engineering as well as digital transformation. Lakshmi is also a tech enthusiast and she's a tech blogger. She has her own newsletter called the Cosmic Signature. If you are in our Space Careers Mastermind community, you would have received an email from me very recently with a link to her blog post. If you missed that, don't worry. I'm going to put the link to her blog again in the comment section. You can check her blog out. And Lakshmi is here today to share her educational journey, her career. And right now, she is also taking a course at the Indian Institute of Science on advanced space technologies. And I'm very, very happy to have you here, Lakshmi. Thanks for joining us all the way from UAE.
Thank you, Sumana. Thank you so much for the kind introduction. And I'm already a fan of all your podcasts and blogs. So thank you so much. It's my pleasure to be here.
That's very kind of you. It's very kind. So I would like to start from the very beginning. I want to know what was that educational journey like that helped you, propelled you towards such an interesting career. So if you could tell us a bit about that.
Yeah, sure. So I started my bachelor's. I did my bachelor's in Bangalore in electronics and communication engineering in an institute called BMSIT. And so that kind of, I think it led me to develop an interest in aerospace. The passion I already had before, but this degree kind of laid a good foundation because you learn a lot of things. Like, for example, you learn control systems, communication systems, and a lot of things like programming with microcontrollers, embedded systems. Basically, you get the confidence to talk to hardware by writing the software, which is a very essential skill. So all these systems and also sensor and instrumentation as well, which is a very key part. So all these systems and these basics, they form like a foundation for aerospace. And in terms, to be specific, they form a foundation for avionics, which is one of the core subjects of aerospace. So this kind of made me really interested in aerospace. And I would like to add one thing, like my final year project, even though it's not related to aerospace, it was in a company called National Semiconductor. It was very interesting because I was developing a system where you could measure like real minute weights, like microgram and milligram, and with the help of an IC, like for example for gold. And I did this from scratch. So I built, like I soldered, I did all the programming, everything, built it like from scratch. And that also gave me the confidence with hardware, which is also a good thing to have. So all these things, I think, kind of led me to aerospace. And I worked for 1.5 years in a software company as soon as I graduated. But as you know, because of the passion, I really couldn't withstand it. And then I tried also to get into aerospace companies, and I got into Moog, which is US-based company. And the experience from there was amazing.
That sounds very interesting. I loved how you said, the conversation between the hardware and the software. That is something an engineer needs to learn. And I remember when I was studying bachelor's in Dehradun, UPS, we had aerospace engineering, but we had two different sections, like aerospace as well as avionics, and
Okay.
students of aerospace and avionics used to constantly have a battle. Avionics people used to say, if we don't build the brain, what is your structure? How is your structure going to fly? So it's just the combination of both that an aerospace engineer really needs to have an understanding of. So I love that. And now you mentioned move, so I'm very interested in uh, hearing about your experience there. I know that you had a very practical experience in the aerospace industry while working at Moog. So if you could tell us a little bit about that.
Yeah, sure. While I was at MOOC, it was based in Bangalore, but I was also posted in US for the testing and all that. I was basically hired as a test engineer, where I got a chance to work with A350 high lift trailing edge flap system. That is, these are the systems which are required for takeoff and landing of A350. So you can imagine, I tested it like almost a decade ago, and you can see the aircraft in production now. So that's how the aerospace industry is. You have to have a lot of patience to wait and see things fly. um, yeah, the experience was amazing because I could see that there is a lot of process involved in this testing. Like how I you could see like how each and every part of the aircraft, how it is built and how it's assembled and also tested. It goes through a rigorous process. Okay, and it's from different parts of the world also, which was I mean a very my mind opening experience, I would say. So this kind of deepened my interest in aerospace. Okay, and I got to know that this is a process oriented field. So I started researching on what kind of process is used. So that time I got to know there's something called systems engineering, which was the approach followed. And this led me to apply to my masters in ISAE Toulouse, which is, I think, one of the most prestigious institutes for aerospace and space. So I applied there and I got accepted. And that's again, it was a life changing decision, I would say. It was amazing.
It must have been. I mean, Toulouse is the hub of aerospace in Europe. So being there, studying there, especially at ISAE, must have been a brilliant experience. And so that started your journey in systems engineering. And I'm really, really curious. I remember the first time we spoke, we talked about systems engineering a lot because that I find it's highly essential in the aerospace industry, but it's not so much covered in our engineering curriculum as much as it should be. And so it's always the practical experience, the industry experience that teaches us what systems engineering really is. So you have had a very nice internship at Rolls-Royce, which was also in systems engineering. So if you could tell us, how you approached that internship, what you learned from that.
Yeah, I think I totally agree with you. You made a very good point, Sumana. There is this systems engineering is one of the lesser known fields. It is you never get to know about it when you're studying engineering. It's like something like an add-on which you learn when you enter the industry. I wish it would be mainstream, and yeah, I've been advocating that as well. And yeah, regarding Rolls-Royce, so luckily I got an opportunity to implement my system engineering skills in practice. So I moved to Rolls-Royce, Germany, which where I was in charge of building a test system, like an integrated or unified test system to test the different engines which are developed at different parts of the world. Like there was like 5 Rolls-Royce sites, and there was one system to be built to so that you can test any engine anywhere and it can be reused, so all this concept can be done with the help only with the help of system engineering, because you have 5 different sites and 5 different cultures, way of working, the way it's documented, and there are also legacy systems. So bringing these systems together and unifying them is a great approach with which could be done only you can see the added value only by applying this process, I would say. And I saw the whole team applying it in real time. And I think Germany being like the known for its precision engineering, it's really an experience to work with in Germany in engineering field. So that was again amazing.
Of course. And, just half an hour ago, I was speaking to a student who is trying to decide where to go to study engineering. And I was like, if you want to study engineering, Germany is, you have to consider Germany. So absolutely. We would come to would love to hear more about your systems engineering experience as well as the experience of working with, like you said, different kinds of cultures from so many different parts of the world. But before that, you have also worked on airport systems. And this is, I was very interested when you explained to me. And this is one career option that is probably a lot of us are not aware of when we study or when we consider a career, and it's pretty interesting from what I heard from you. So could you share that with us? Like elaborate what it was to work on airport systems.
Yeah, sure. Yeah, to be honest, even I was not aware of this option until I got the job offer. So, yeah, this is one of the very less known fields, and I believe it there needs to be a lot of spotlight shed on it because that's how interesting it is. So, yeah, after my system engineering degree, I worked in India for a while, and again with CS Communications, that was on aircraft systems. But I also got the opportunity in Abu Dhabi International Airport to work on ATM systems, that is air traffic management systems, which I just blindly took it and I moved here. And uh, I can say it's again a very different experience than aircraft systems. So in aircraft systems, you have parts being manufactured and assembled different parts of the world. Here, the thing is, you have all the stakeholders together, and usually, yes, you have multiple suppliers, but they all have to come to the airport in the end to install it. And in airport, the thing is, you have operations like you can see takeoff, landing, all the runway operations on a daily basis and 24 hours. So any issue is critical and it has to be resolved with the within a minimal time as soon as possible, because you cannot have compromise on the runway safety or anything. And so yeah, I'll just give you a brief of the project I did. So it's called ASMGCS, that is Airfield Surface Movement Guidance Control System. So it's a big acronym. So it's basically the ground system which the controller is using, the screen which the controller views, where you have all the information such as lighting, which is essential. I think you see it whenever you land and take off. And then you have surveillance because you need to see where the position of the aircraft is or any vehicle is. You need to be aware of everything. And there is also some intelligence on top of it. Like you have some safety nets, you have like runway incursion measures, taxiway incursion measures, just to make sure there are no incursions. Like you can predict incursions. Like uh, if two entities are coming together with and by measuring their average speeds, there's an alert on the screen. These are all like advanced or novel state of the art systems which are being developed now. And I was lucky that I got a chance to work with it because it's one screen. Like before they used to have many screens and they have to keep moving their head, and they have to keep moving to even control and monitor. So this one screen kind of gives you a unified attention, and the system being more automatic lessens the controller workload as well. So he can just focus on the safety aspects and not get worried like, oh, where the button is, and those kind of things. So this system was had two main concepts. So one was to like automate the routing. So by that I mean, like, once an aircraft lands on a runway, the system will suggest a route and like to the stand, to the assigned stand, and the controller has to select it. If he's okay with it, he selects it or he just modifies it. like usually the system is right. So he selects it, and then the aircraft just follows the green lights, and then this proceeds to the stand. And same way with the stand to the runway as well. So it's like automatic moving of aircrafts. The whole flow on the ground is automatic, which is really good. Like, and you don't have collisions. I mean, this is like the best case scenario. And even when you have low visibility, your weather system is also integrated, because that's one of the main system. And the landing system, instrument landing system, we call it the ILS, that's also integrated. And also the visual guidance docking system that is used for docking the aircraft to the stand safely is also integrated. So you have all these information in one place, which is kind of very helpful to the controller. And it's like a paradigm shift. Initially, we were using like paper strips to move from one place to the other, like from arrival bay to departure bay, and then we moved to electronic strips. And now this is like another. It's like a huge iPad, I would say. And this, you just control it. You see things moving and you control it. That's good. And the other part was, we also have to focus on sustainability, because you can in airport, like you have like tens, 10 to 15,000 lights if you have a average airport. Yeah, I know you are a big fan of that, and me too. So we cannot keep the lights on all the time. During day, the lights are not on usually, but during night also we should switch on the lights which are just essential for the aircraft. So by using this concept, we also save a lot of lighting, because we just switch on the essential lights, and then not like the whole all the unnecessary lights are off. So this way, it's also contributing to the energy. And we also use LED lightings, which even they're better than halogen. So that way, we save more energy. So yeah, it was a great experience, and I think if anybody wants to get a chance, I mean, there are a lot of smart airports being built across the world, even across India. So if you get a chance, it would be really good to experience this.
Yeah, it sounds wonderful. It sounds very interesting. And, I'm anyway very excited about whenever I see those mission control rooms or be it at ATC, you see all those screens. It just something very futuristic, but it's very real also. It happens in real time to me. And you mentioned the lights switching off, and I heard that you're conserving energy, and already the green flag went on in my head. And the other thing is, in general, what you explained, I feel, be it aviation or space, I think a lot of the technology is just to ensure safety in in the entire spectrum of aerospace. Yeah, that's one thing. I mean, for the work that you did, and for everyone else that are working on ensuring such safe systems across airports. So, one of my closest friends is a pilot. She and her partner are both pilots. I never say this to her, but whenever I see those news that something has gone wrong during the takeoff, my heart just, stops for a minute. So I'm glad that so much effort you've put, and so much effort other professionals also put in ensuring that everything goes according to the process, everything goes in the nominal mode, like we say. So thanks a lot for sharing that.
Thank you so much for highlighting on the safety part. Yes, whether it's aircraft or airport, in general, aerospace and space, I think safety is first. And this field is like highly regulatory in nature. And I think safety already starts from the requirement stage. Um, in the systems engineering, you have to incorporate safety requirements, and then that trickle down to the design stage, where you kind of decide, you do some failure mode analysis. A lot of failure analysis methods are there, like FMEA, FTA. So all these are done, and you decide like which component has to be redundant and how redundant it should be. So all these aspects are considered, and yes, thank you so much for highlighting safety and regulatory. Yes, thank you.
Oh, yes, the other part, the redundant systems, the concept of redundancy in aerospace is also something I think what makes aerospace a little different from other industries. I mean, even automotive industries or other industries also have redundancy, but here it's a matter of safety issue. Uh, in space, it's a matter of billions of dollars as well as sometimes lives. So in aviation, it's always, most cases, it's lives. So I'm very happy. And I'm glad you touched upon requirements because that's what I really, really want to learn from you in detail. That the concepts of systems engineering, right from requirements definition, we have the design, we have uh, different reviews, traceability, verification, validation, all of this. How do these elements really, it's a complex process building a whole aerospace system. It takes a lot of time, a lot of people, and usually all of them are spread in different parts. There's no one small house building everything. So how do these different elements of systems engineering really come together when our aerospace system is being built?
Yeah, sure. I think systems engineering as a concept, it started with NASA for space systems, and then it was applied to aerospace systems as well. And it can be applied to other fields as well, like automotive, energy, or transportation, or smart cities, because all of them work on the same complex systems, which are like multidisciplinary problems. By this, I mean like software, hardware, multiple software, hardware, firmware. So applying this concepts kind of gives you a holistic perspective. So there is a saying like the properties of the sum of the system is not the same as the property of the system itself. This property of the system is like they call it emergence. It's a very different than the sum of just the mere sum of the subsystems. So yeah, taking that concept, there is something like called V model. So in this V model, that's like the core or heart of system engineering, which every engineer follows, whether it's a component or a subsystem or like a whole system. However you want, you can follow that. And so here in the V model, in the left, there is like a requirements and design. Okay, requirements, detailed design, and sorry, requirements, preliminary design, and detailed design. Yeah. And then in the middle, you have implementation, system implementation. On the right, you have like unit testing and subsystem level testing, system testing, and also in the last, you have acceptance testing. How these components interact is, first of all, we'll start off with the mission statement, which is given by the group of stakeholders who are sitting together. They're like operators and users, say safety people, regulatory people, everybody's, and investors. Everybody sits in a table and they come up with concept of operations and the mission statement. Like, what is the system supposed to do? What is its mission? Okay. And once you have this mission, it will be broken down into use cases. Like, for example, the mission of a commercial aircraft is to fly passengers safely from this point A to point B. So for cargo aircraft, it's to transport the cargo safely from point A to point B. So this is, I'm just giving you an example, but it can have multiple use cases as well, the system. So from this mission statement and concept of operation, what a system developer or a company, system development company, does is they will extract the system requirements, and they spend a lot of time in this phase, because there is a concept in system engineering called a problem which is well defined is a problem half solved. So you need to focus on defining the problem well. Okay, first, because if you got that wrong, then it will just, the effect will just propagate till testing, and you have a lot of loss in cost or and effort as well, and time. So this is the first thing. You have developed the system requirements by gathering requirements, having multiple sessions, going through multiple reviews. Then you finally come up with a system requirement document, which is consisting of both software, hardware, everything. And then it will be baselined, and it will be approved. By baseline, I mean there is some kind of version control management or configuration management. Then it will be approved. Till it's approved, you cannot go to the next stage. And in preliminary design stage or a high level design, whatever you want to call it, so we take the requirements and come up with the high level design, but we do not make any technology choices. So the main thing is the system has to be requirement driven and not technology driven, because you don't want to get attached to some technology. Okay, there is AI and I want to just, develop this with AI. No, you should stick to the requirements and see how the requirements itself defines the technology. So in the next stage, you will see the technology being defined. Like that is the detailed design. Then you go to the implementation. Okay, so once it's implemented, all these has approvals and they have their documents and all that. So once it's implemented, what you have is unit level testing. So the detailed design, which was the last but one stage, it's tested with the as a component or a unit. So there is some testing done for that. And then you have the high level design on which subsystem level testing is done. Then you have the requirements itself on which system testing is done. So that's how the V goes, kind of. So finally, like the user acceptance testing will be done with the user requirements. And there are two concepts in testing. As a like because of the experience in testing, usually there is verification where you say, did you build the product right? And validation, did you build the right product? So validation is the acceptance testing, which is applicable to the last stage. So after this, the system will go into operation and maintenance once all this is finished. But later you will still have changes and upgrades unless you want to retire the system. So even these changes and upgrades will again go through the V model. So this is something which is, this system engineering approach, I feel it's very important. And the main thing is you have traceability throughout the V model. Like if something happens, you can quickly trace where you went wrong. And next time in the like a lesson learned, or in the next projects, you should make sure that you don't do the same mistake again. So this is kind of the basics.
I loved how you explained the entire V model and the entire systems engineering process. And to everyone listening, I would just want to say that this is not, again, I'm going to stress that this is not a core subject that we study, especially in our bachelor's, but usually. But if you can understand this part, it's a highly essential part of any engineering design until execution. The iterations that it goes through, a whole system that it goes through, the fact that it could be traced is it kind of reduces the complexity in a certain way. But also, what I want to ask, like a follow-up question, is that at what point is a systems engineer satisfied with the iterations?
Okay, I think the point where the system requirements are tested against the system test procedure or the plan, that's kind of the step where you kind of get confidence. Like, okay. And finally, when you test it with the user requirements, you have to develop the factory acceptance procedure or site acceptance procedure, depending on where the system is. Because usually system is developed in factory and there is a test which is witnessed by the client there, and then it's shipped to site if they're satisfied. So yeah, at this stage, at the acceptance test, you will already know if you have done it yourself, like before the client comes, you will already know if your system is good or not. And if in the previous levels of testing, also if something has gone like fundamentally wrong, I think you will identify them in subsystem level tests, or worst case in system tests.
Yeah, that makes sense. And the other thing is, I loved that you said that the mission should be requirements driven, like the requirements should be met. and not technology driven. A lot of questions that I get recently is from students usually, that how much of AI is being really used in space, how much of AI is being really used to go to other planets. And the fact that technology changes rapidly, but a space mission takes 10, 20 years maybe for a deep space mission. So it's always a complicated topic to explain, that while ever evolving technology is very exciting, but aerospace is a very kind of risk averse industry, because it has to, because there are a lot of uncertainties, a lot of safety measures, a lot of cost involved in the entire field. So I'm very happy that you touched upon that. And there is another really great aspect of your career, which I find very interesting, is that so many different countries, so many different cultures, and you're currently in UAE also now, you're from India. And if I ask you, what has been your biggest takeaway having lived and studied and worked in so many different places?
Yeah, thanks so much for highlighting that the technology really evolves, and you cannot really be sure. Like an aircraft which is being released a decade from now, you don't know which technology to actually put. So it's not an easy answer at all. So, but yeah, the each and every field is evolving with technology. I can say there are small elements of AI also being added. Regarding my international experience, I think I was lucky enough to get a chance to study and work in countries. So I worked around Asia, Middle East, Europe, and US. And as you know, all of them have different cultures, and it's really it enriches you personally and professionally. So I can just give you some examples. Like while you're solving a problem, uh, a system related problem in aerospace, you will see how each and every country, or how the environment in each country kind of solved it, or how they approached it. And then you start to think about those different kind of approaches when you see a problem. That is one thing. And there is also various international standards, even though they are almost the same, but yeah, you have some differences, so you have to keep that in mind for sure. And then yeah, it also increases your creativity, your adaptability, your networking. You meet a lot of people, and like develop a lot of network opportunities, which later turn into learning opportunities, or maybe even business opportunities later in the future. And that's something very it's a very positive outcome. And I would say there's also language, which is one of the main concerns. And yeah, that was an interesting experience, especially in Europe, where it's quite language driven. So you have to kind of show interest in the learning the language, at least the basics, which will help you network better with people and even understand when they're discussing some concepts. That and the other thing is, it kind of makes you independent. uh, by this I mean, like, you learn to start making your own decisions, like, quite easily. Because for example, if you are representing your Indian team and you are in US or Europe, you don't have your counterpart always available. So cannot be dependent on them. You have to take some uh, quick decisions which will influence the course of the project, which is also very important. You learn that skill, it just becomes a part of you. Yeah, you are like, you push out of your comfort zone, and but it's a very positive change, I would say.
Yeah, definitely. Adaptability. I think without, if be it language or any kind of cultural integration, it's only possible when you're adaptable, like not being too stubborn. So I loved, and the way you have well blended with in different cultures, it just proves that, uh, it's it's not just technical knowledge, it's a lot of other kinds of skills that we need to develop. And I do have one question for you, but before that, I do have an offbeat question also that just suddenly popped in my mind. Is you worked on airport systems. I want to ask something about a recent development in India, which is how beautiful do you think is the new Bangalore airport?
Yeah, sure. So Bangalore Airport, I mean, it's the airport which I usually visit and use the most. And I think T2 as such is amazing. It was built on a very good concepts like sustainability, and they're also promoting art and tech at the same time, which is, a, it's very unique. You don't see this often. And Bangalore being a very tech oriented city, they wanted to integrate tech. You also have this Digi Yatra and all that. I think that you have in other airports as well. So in terms of sustainability, I think they did a great job by getting various species of trees, and I think it was like hundreds of species of trees from somewhere and planting it from various parts of India, I think. Yeah, in general, it was really good, my experience when I went there.
That's lovely, lovely to hear. And sorry for that digression, but I've just been seeing pictures and videos of it, and I think it's beautiful the way they've done it. Yeah. So, Lakshmi, this one thing that when I asked this question to a guest, that what advice do you have for aerospace engineers? The one thing that I want to know is that aerospace people are trying to study aerospace because it sounds in our generation or Gen Z words, it's cool. It is cool. It is fascinating. All of that is there, but there's also the always the fear that we won't have good jobs, or there's also a question that comes very often is that I am not going to get as paid as my CS classmates, batchmates. You know, they're getting huge packages, and we don't even know. We have so much uncertainty. We don't know which job to go for. So my question to you is: you have gone through a very long career, and you're still working. You're still providing systems engineering and training services in the field of aviation. So if you could tell us, just holistically, is it worth studying aerospace and considering a career in this field?
Yeah. So if you're able to do an aerospace degree, it's well and good. Otherwise, you can also pursue in degrees like electronics or electrical, mechanical, or even CS software. So I think the main thing driving this field is passion, just like space. It's like you have to be passion oriented and motivated. That's what I saw in different parts of the world as well. And this has to be there from beginning, because you have to have a lot of patience. Like for example, I said it takes a decade for an aircraft to make its first flight and fly and go into production and all that. So you will see some things which are moving slowly, but you will see things moving for sure. So the main thing is to pursue this. You need to have the passion, of course, and you need to have the basics of all this electrical, electronics, mechanical, software, all this, right? And regarding the demand for this, I think air travel is always in demand. Even after COVID, we have seen like a rapid rise in the air travel demand. And so that is something which you don't need to be worried of. And there's also a lot of innovation coming in this field. So like you have something like eVTOLs, so that is vertical takeoff and landing. It's mainly it's developed in urban like cities to ease off the ground traffic, so that you can have, it's something like an air taxi. So, and to accommodate this, you have vertiports as well. So you have an aircraft and you have a new type of aircraft and new type of airport as well. So all these kind of concepts, they're coming in, and with this great digital transformation which is happening in all industries, and AI has penetrated everything. It has penetrated aviation as well. So there are some future trends, something like because if you want to stay updated and work with the latest systems, I think it's a great interesting experience. For example, what I've seen is like in the simulators, the cockpit simulator or the tower simulator, where the controllers or pilots are trained, you have virtual reality, like it enhances the training, and it improves it. And there's a lot of robotics and 3D printing, which is applied in manufacturing. So that is also developing rapidly. And you have smart airports. In case of airports, everything is becoming like contactless and hyper personalized, So even if you are like a core software engineer, you can just keep developing apps for airports, which is also something very interesting. And you have electrical systems. So not to miss sustainability, there is this urgent need, because air travel is one of the great contributors, unfortunately, because of the fuel and the contrails which it leaves when it takes off. So this also has to be tackled. So we cannot just keep having traditional type of aircraft. So electric systems have to come in place and they have to take over. And this is also a very interesting transition, I would say, from fossil fuels to this thing. And you also have sustainable air fuels. So it's a very diverse field. Like whatever, if you're interested in something particular, you can just go and pick it and you will have opportunities. And even in India, there are a lot of airports coming up. At least, I think last year I read there are at least 100 new airports coming up. Even in the tier 2 towns, I think you have a lot of airports now. So which gives a chance for everybody to work in this sector. And regarding aircraft systems, India is having its own startups in some of the aircraft and space startups as well. So the ecosystem is really thriving, and I think a lot of aerospace companies from other countries are also having their office now in India. It's increased a lot, and you have some Bangalore, NCR as Pune as the hubs of aviation, at least for aerospace systems, which is you still have a lot of career opportunities. And if you want to pursue masters, of course, Europe is there. It's quite open, and US is also there, and Middle East as well. It's developing very well with the opportunities, which is, it's really great to see the industries evolve like this. So if you want to pursue this field, I would suggest please start participating in like some research projects, write papers or small passion projects also you can do, participate in competitions, listen to webinars like this and podcasts, and also relevant newsletters. Stay updated with the latest news in the industry. Also in LinkedIn, build a good LinkedIn profile and stay network with the right people. So yeah, these are some common tips. Also, if you can, if you're interested in writing, please write about the topic, because it really improves your research skills and analytical skills. I've been doing it over the past few years, and it's really therapeutic as well. And same with Sumana as well. I realized. So yeah.
That's a really great advice. It's just there's nothing. That's what I think. It's aerospace is called a niche. Aviation and aerospace is called a niche industry. But what I feel is it's a it's where all the industries come together. An aerospace or aircraft or a spacecraft has all systems. Like you said, it's not necessary that you have to study aerospace engineering. In fact, an electronics engineer or a software engineer can contribute a lot more in the early phases of the mission if they have that right domain knowledge. And but yes, passion is there, but patience is also needed. This one research organization I volunteer with, and we are building a deep space mission, which the concept of it, and which, if it is executed, will probably happen towards the end of my lifetime. I won't be there to see it unless someone finds a way for humans to live naturally for 150 years. But it's still the joy of it, to contribute and to develop new things and to see, you're building the concept of something now that is going to happen in 2060s. it has a different kind of that adrenaline rush that you get. So that is, I think, aerospace industry offers, even if it can't offer a huge salary like some other industries, but it also is, like you said, it's a growing industry. It is growing everywhere. So I think it's not that much of a gloomy situation. No, it's not that bad.
Yeah, in terms of compensation as well, I think it's getting very good. It's getting much better, and yes, you do require a lot of patience, as you highlighted, for the especially for aerospace and space missions. It's very true. And I would just like to add one point. And being an advocate for diversity and inclusion, I really would. It's a shout out to all the women. Please come to this field because we need more of you. Because of the mainly because it's a very interesting field, and it's not at all a masculine field. You will you will just enjoy the experience. So
Thank you. Thanks a lot for saying that. There's every female student or a professional listening to this. There's nothing scary about aerospace. There is no. I think someday you were talking about writing. That whatever you're learning, write about it, which I always encourage. I think I wrote on LinkedIn one day that there was no course during our studies, or there was nothing during our when we started our career that said, you have, if you're a woman, you can't learn this. There's no such thing. It's something that anyone can learn. Anyone from any background can learn. All you have to do is you have to keep at it. You can't just lose patience, and it's difficult, it's complex, but it's definitely doable. So thank you so much for saying that. Thanks a lot. I think in order to really consider a career in this field, I mean, education, definitely a good technical education, but beyond that, like you said, staying updated into really what's happening, rather than drawing these imaginary pictures. Okay, we get a lot of projections saying we have a huge, some $100 billion we're going to cross, rather than traveling into that zone. Just speaking to people who are really into this field, like learning from you what you told us today about, be it systems engineering or about airport systems. It's these connections, the networking that you mentioned. It's this building these professional relationships is what I feel. That's how I started growing. That's what I do even now, because I'm still at the very initial stages. So this is very enriching, these kind of conversations. The real life, what we call aerospace professionals, are the ones that can tell us that it's very possible. There's one very beautiful thing whenever I speak to professionals like you, they always stress upon the international regulations that you said, that if you want to work in aerospace, you need to be aware of certain regulations. And I do find a lot of engineers have that kind of mindset, we'll just focus on the tech. But it does not work like that. You do have to know compliances. You do have to know a lot of rules and regulations. And I do encourage everyone to really speak to people a lot more. Network beyond asking for a job or a reference for a job. That's not what networking is. There's a lot to learn from everyone. Lakshmi, thank you so much for being here with us today. To everyone watching, I'm going to put Lakshmi's blog link in the comments, and please subscribe to her blog, Cosmic Signature. She really writes very beautifully on different okay, I'm not going to reveal it. You go and check it out. And there's other thing, if you want to join our Space Careers Mastermind community, I'll also put that link in the comments. It's a free community. It's a community for all of you to stay updated about what's happening, and not just that, learn about real space tech concepts. That's what I send the emails about things that incidentally, I did send a PDF about systems engineering the last time, I remember. So I'm trying to grow that. We have a Facebook group for that community. If you are on social media, I encourage you to go to that Facebook group and share what you like about aerospace. The more you start interacting, the better the community feel you get. And I'm also trying to shift that to a non-social media platform where everyone can share, because not everyone is on social media. But beyond that, I hope this podcast was helpful. Lakshmi, I had a wonderful time listening to you. Thanks so much.
Thank you so much, Sumana, as well. It was a very nice conversation, and thanks to your amazing questions and your inputs as well. It's really my pleasure to be here, and I really hope I inspired some young minds.